Hello everyone, my name is James and today we're going to be discussing kinematics. So kinematics is essentially a branch of mechanics that observes the motion of objects without including the forces involved. So if we take a look at this diagram here, we can see that the causes of motion are basically divided into multiple categories. So we have what motion that occurs in the x-axis, so this motion is considered linear. We have motion that occurs in the xy axis, so this can be considered parabolic or circular. XYZ axis, this is 3D motion, and we also have moving in a frame of reference, so like how an object moves relative to another object. So these different categories of motion can all be described through kinematics. So what exactly are we talking about with kinematics? So we're going to look a little bit into what is involved in the different parts of kinematics, but in order to understand that, we need to know what vectors are. So vectors are numbers with magnitude and direction. So if we take a look at these two examples here, the first of which we have 16 meters east. So if someone tells you 16 meters east is essentially a displacement vector where we're looking at something that's pointing to the right, and we also have a value associated with it. In the same facet, we also have 20 feet south. So there's an arrow that's pointing downward, so there's a direction, and the magnitude associated with it is 20 feet. So when we look at vectors, these vectors can sometimes come with components. So what does that mean? So if we look at think about the previous example where we have arrows pointing solidly in one direction versus the other, we usually only have one component that has value. However, if we look at this arrow here where we see an arrow pointing at 30 degrees northeast, we know that we have two different components involved. We have the x component, which is represented by velocity times cosine theta, and we have the y component, which is represented by velocity times sine theta. So here, because we have something it has basically a part that is represented by the x direction and a part that's represented by the y direction, we can represent this using trigonometry. So how can we solve if we know the x and y components and we want to find the total vector, or if we know the total vector and one of the components and we want to find the other component? So we can use Pythagorean theorem in order to solve this. So say that we know the x vector and the y vector. We can determine the resultant vector by using this Pythagorean theorem: a squared plus b squared equals c squared. In the same facet, if we want to determine direction of the resultant vector, we can use the two component values in a trigonometry equation. So we can say the tangent of the theta, so theta here being the angle that results from the resultant vector, equals b over a, so the y component over the x component. Both of these equations together can give us the different pieces of information that we need in order to know everything that we need to know about the resultant vector. So vectors can also be used in multiplication. So there's two types of multiplication we can use with these vectors. There's a dot product and then there's the cross product. So the dot product is your typical multiplication where you just represent it by a dot that you would normally use, and also it's just essentially meaning that you're multiplying the magnitude of A, which is like a vector, magnitude of B, another vector, and then multiplying the two values by the cosine of the angle between the two vectors. In the same angle, we're kind of looking at multiplication as well with a cross product, which involves A cross B, which you can solve by looking at the magnitude of A multiplied by the magnitude of B multiplied by sine theta. So we just talked about vectors. So vectors have magnitude and direction. Now scalars don't have any value in terms of direction. They only have value with magnitude. So if we take a look at these examples, we can see two apples. So we know the amount 2. There's nothing describing direction of motion of the apples. There's nothing describing, what velocity that these apples have. We just know that there's 2. Here also on the right, we have 3 textbooks. Once again, 3 items present, nothing known about motion or direction or anything. It's just 3 textbooks. We're just looking at the magnitude value of scalars. So why does it matter? Why do vectors and scalars matter? Well, vectors and scalars describe some of the variables that we'll be looking at in kinematics. So if we take a look here, velocity and acceleration, both of which we'll be discussing later, are vectors. So these variables observed magnitude and direction. And scalars we will see through displacement and time. So displacement and time only have a magnitude value, but they're not associated with a certain direction. So the equations for kinematics that we have to know. So the kinematics, we want linear motion. So we're focusing on just that motion, not worrying about any changes that are occurring, just that motion. So and any forces involved, we don't have to worry about it here. So there's four equations that we typically consider with kinematics. So we have, if we just look at this chart here, and they're also correlated here as well, the equations by themselves. But if we look here, we can consider the final velocity, and we can find this value by adding the initial velocity of an object plus its acceleration times time. And then if we look here, we can see like the units associated with all the variables. So velocity, both initial and final, are meters per second. Acceleration is represented by meters per second squared, and time is represented by seconds. And knowing these units is very important because it helps us understand kind of why these equations are arranged the way they are, and that no matter what values we put in, we will always receive the correct units for all values involved. In the next equation, we see that we can determine distance by using the average velocity. So if we add the final velocity plus the initial velocity, multiply that by 1/2, and then multiply that value by time, we're able to get displacement. In the next example, we can also see that displacement can be calculated by taking the initial velocity value multiplied by the amount of time traveled plus 1/2 times the acceleration of the object times time squared, so the amount of time that is being traveled once again by that object. And then finally, we can determine final velocity by taking this equation. So this equation doesn't consider the variable of time. So if we look at this, we can see that the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times displacement. So all these equations together will allow us to determine different variables in different kinematics problems. The key to doing it correctly is knowing which equation to use in what situation. So we're going to take a look at an example later on that will help us recognize this. So just to go over kinematics, so like why does kinematics even matter to us? You know, why do we have to know how something moves or where something will be in a certain amount of time? Well, we see kinematics everywhere, but a big example of that is in sports. So if you take a look at the left, someone throwing a baseball, here in this case a pitcher, has to know how much time it will take for the ball to reach the home plate. This way that they know how to, strategize against the batter, and also to plan exactly how much time they have before the batter reacts and hits the ball and they need to go after it. Also on the right, we have volleyball. So volleyball actually involves an interesting topic called projectile motion, which we will discuss in a different video, that basically involves gravity and how this force can interact with the velocity and acceleration of motion, in this case with a volleyball. So the example that we're going to go over is basically going to help us understand kind of how we're going to select the equation we want to use with kinematics, and also, how to apply that equation and solve. So in this example, run Veer threw a baseball from a starting speed of 0 meters per second in a straight line to his friend Nathan batting at the home plate. What was the speed of Ranveer's pitch 3 seconds after release from his hand, considering the acceleration of Ranveer's pitch to be 5 meters per second squared? Alright, so the first step we want to do with a problem like this is to acknowledge what information we know. So here we know the time of travel to be 3 seconds, the starting velocity to be 0 meters per second, and the acceleration of the pitch to be 5 meters per second squared. So we have these 3 key pieces of information. Now that we have this all written down, we want to consider what information we want to learn. In this case, we want to learn what is the velocity following 3 seconds of travel for the ball. So the next step, once we know what we want and we know what we have, we can consider which equation shall we use. So if we want to know the amount of velocity, so that here the final velocity after a certain period of time, and we know the time of travel, the initial velocity, and the acceleration of the pitch, we are able to figure out that we would like the first equation, where we observe the final velocity, the starting velocity, the acceleration, and the time. Now that we know which equation we want to use, we are able to apply it here with the values that we have collected. So we can plug in for the values that we know with initial velocity, acceleration, and time. And then we are able to solve in order to get the correct answer of 15 meters per second for the final velocity of the ball following 3 seconds of travel. Now that we are able to solve that, we can go over kind of what we learned about kinematics and the different values associated with it. So we learned about two different types of values that can be represented of variables. So we learned about vectors, which have magnitude and direction, and we also learned about scalars, which only have magnitude. Kinematics, in general, studies the motion of objects without looking at involved forces. So we're just looking at the motion of the object, how fast it's moving, what exactly is happening over a certain amount of time, over a certain amount of distance, and we can use these four equations in order to help us solve different parts of the problem at hand, as long as we acknowledge what information we know and what information we need. With that in mind, I know that we can solve any kinematics problem that comes up on the MCAT. I wish you all the best, and thank you so much for watching this video.